Positively perfect problem solving presents modeling with functions. We've talked a lot about function notation. We've talked about domain and range. We've talked about a lot of things that are really abstract and have no purpose. So today's learning target is giving us some reasons for why we use these things we've been learning. So we're going to talk about the variables we use and what they apply to. We've used the phrase input and output a lot. We're going to assign input and output in two new variable names. So we have independent variable and dependent variable. So the independent variable is a very fancy word for the input value. Okay, so the independent variable is what we input into the function. The other fancy word we're going to use to describe the independent variable, there's two kind of ways we can describe it, is a variable whose value is freely chosen, meaning you can pick whatever you want to put in there. Okay. The dependent variable is the output of a function. And in fancy language, we call this a variable that depends on another variable. Meaning we can't really freely choose this variable. This variable appears once we change another variable. Okay, so independent input, that's one way I remember input. What it applies to is they both start with I. So input and independent both start with I. So how do we connect that to function notation? So this is our rule for function notation. So we talked about that y being an output and the x being the input. So in other words, we can call output the dependent variable. Actually, let me use the matching colors here so we can get a little bit better. So your output is dependent, and then your input is independent. So that little x right there is independent. All right, now how does all of this apply to a real problem? So here's a real problem. Okay, Amanda babysits and charges $5 per hour. Cool, good for you, Amanda. That's just a fact. She babysits and she charges $5 per hour. So the first question is, how many variables are there? In this particular example, there are actually two variables. Let me use a color here that we haven't used yet. There are actually two variables here. There's two things going on. One variable is the amount of hours that she's charging or that she's wanting to have. Like, I don't know, if I'm going out and I'm, you want to leave your kids or whatever, how many hours are you going to be gone? I don't know, maybe 4 or 5, whatever. That's a variable. It varies. The other variable is the cost. Right? Depending on how many hours I'm at, my cost is going to change. Okay, it is $5 an hour, but if I'm out for 4 hours, I'm paying $20. That changes based on how many hours I'm out. So these are the two variables we have. Now this next question is asking, how much will Amanda make and how many hours does she babysit? Well, how much Amanda makes, that's an interesting question. I don't know how much she makes. It depends on how many hours she babysits. So I'm using this word changes to think about the problem. And here's where we're going to think about what changes what. The hours that you're gone to leave your kids at home changes how much money that she's going to get. It changes her income. It changes the cost. In fact, let's write cost to make it more clear. So the hours changes the cost. If I'm out for 2 hours, it charges 10, 3 hours, 15. So the hours change the cost. It's not the other way around. The cost doesn't change the hours. Okay, when I hire a babysitter, I don't think, okay, I'm only going to spend $20 So I have to only be out for 4 hours exactly. Usually when you hire a babysitter, you're like, yeah, I'll be gone between 4 and 5, I don't know. And then when you get home, she tells you how much you need to pay, whatever. So how many hours you're out changes the cost, okay? With that said, the free thing you're choosing how many hours you want to go out. You're choosing that. So when we talked about independent variable, remember, we define that thing as being freely chosen. So I'm choosing how many hours I want to go out. So that makes hours my independent variable. Oh, I spelled independent wrong. My dependent variable is going to be my cost, because the cost depends on the hours. Okay, so the dependent variable is my cost. Another way we can write this besides using the word change is we can say that cost depends on the hours. And in this way, when you see cost depends, that means cost is your dependent variable. Okay. If I want to write this problem out using function notation, for example, this how much will Amanda make question, in function notation, hours is our independent variable. And if you remember up here, I said the independent variable is that input. So when I write this, I'm going to put f of h. I'm putting an h because the independent input variable is h. So I'm going to use h as my independent variable, and that's going to equal 5 times h, because however many hours I leave the babysitter, if I leave the babysitter alone for 5 hours, I'll pay 5 times 5 and pay her $25. So that's how I'd write my function for this problem. The last question I have is whether this problem is discrete or continuous. And discrete or continuous is interesting. Remember, discrete means I have points, like little points on the graph. Continuous means that it goes on, it's all connected, so a continuous graph could potentially have decimals. So when I think if something is points or decimals, I'm going to say that this particular problem is going to be discrete. It's discrete because I can only be gone 1, 2, 3, 4, etc. hours. I can't really get paid for, I can't charge Amanda, or she can't charge me for 1.23. Like if I'm gone for an hour and 20 minutes, she's probably going to charge me the 2 hours and round up. She's not going to like figure out how to divide her $5, right? So this would be a discrete graph. And I'll show you a little bit more clearly. If I were to draw the graph of this, and here's my hours down here, and here's my cost, 5, 10, 15, 20. After 1 hour, she's going to charge me 5. After 2 hours, 10. 3 hours, 15. So do you see how it's like little dots? It's not connected, so it's discrete. So we're kind of combining everything we have learned from the last 3 learning targets into this one with modeling. Okay, let's check out a few more examples of this. The cost of shipping a package is based on its weight. So if I go to the post office and I want to ship a package, the dude's going to put it on the scale and he's going to say, okay, this is the cost of shipping. So what I'm freely picking is what I'm putting in that package. I'm freely deciding how much that package weighs before I go to the post office. I'm not freely picking the cost. When I'm at home putting something in a package, I'm not determining the cost. I'm picking the weight. So the weight of the package changes the cost of the package. So the weight is my independent variable, because that's what I'm inputting into my package, right? The dependent variable is the cost. The cost depends on the weight, right? Cost depends on the weight. Is this going to be a discrete or continuous graph? Well, when I think about going to the post office, I don't know if you guys have ever been there, when you go to the post office, it's not like it weighs 1, 2, 3, 4, 5. It could weigh maybe 2.5, or it could weigh 3.75. So because I'm getting decimals, this graph is going to look something like this, because you can have decimals, right? If it weighs 1, 2, 3, 4, 5, since it could also weigh somewhere between 1 and 2, it could weigh somewhere between here and here, it could weigh 3. The potential points really could be anything because the package could weigh fractions and decimals. So that makes it continuous. The larger the family, the more meals need to be prepared. So if I'm feeding 2 kids, I have 2 meals. If I'm feeding 3 kids, I have 3 meals. So if I'm picking how many kids I want to have, I'm not necessarily picking how many meals I want to have. I'm choosing my family size. Then that means the family size changes the meals, the amount of meals. So my independent variable is family size because I'm choosing that. That's my input. And the dependent variable is my meals. My meals depend on how big the family is. Whether it's discrete or continuous, to me, this is an easy choice. This has to be discrete. You can't have fraction children. I can't have 1.3 children. That's not how it works. So I'm having individual little points. I'm having either 1, 2, 3, 4 distinct points, which makes it discrete. Okay. Let's take this one step further. Oh, we have one more example. I forgot about this one. Okay, in the winter, more electricity is used when the outside temperature goes down, and less is used when the outside temperature rises. So what is changing what? Okay, and this is important because we're not really choosing anything. We're not choosing the electricity, really. We're not choosing the temperature. However, we have to think about what depends on what. And in this case, the temperature, depending on what the temperature is outside, we can't control the temperature. It just happens. The temperature changes the electricity. If it's 52 degrees one day, I can't control the electricity. I have to deal with that temperature that's happening, and that electricity depends on the temperature. So in that case, my independent variable is temperature, and my dependent variable is electricity. Okay. In this case, I'm going to say this is continuous, because when they measure electricity, and it's very confusing, electricity is not really my jam, but a guy comes out and checks your meter and sees how much electricity you're using, and it could be a decimal, it could be a fraction. So in this case, it is continuous. It could be a fraction or decimal. So we've talked a little bit about specific variables and whether they're independent, dependent. Well, now let's apply that to a real problem. Okay, so the admission fee at a carnival is $9, meaning the minute you go into the carnival, you pay $9 to get in. Then you have to pay for rides. Each ride costs $1.75. So how much does it cost to go to the carnival, and what would you spend if you went on 12 rides? So first, let's think about our independent and dependent variable. So what are you choosing to do when you go to the carnival? Think about your free choice. You are choosing how many rides you go on. And those number of rides changes how much you pay. It changes the cost. If you go on 2 rides, you pay a certain amount. 3 rides, you pay a certain amount. So your independent variable is the rides, and your dependent variable is the cost. Cost depends on the rides. That's really important. So when we want to write this as a function in function notation, the rides is our input, so I'm going to put f of r. I'm going to put r in there as my input, And then I'm going to think about how I calculate rides. How I calculate the cost of being at the carnival, I'm paying $9 no matter what. So $9 is something I'm paying regardless. And then whatever my ride cost is, I'm going to add to that $9. So the ride costs $1.75, and then I have to multiply that by R depending on how many rides I go on. So that's the function that I want. Now to evaluate that function, I know that she's going to go on 12 rides, or whoever this is happening to. So I'm going to replace the R with 12. And then I'm going to solve this problem. So wherever I see R, I'm going to put in 12. Then I'm going to evaluate this. So my pen is being weird. So I'm going to put f of 12, keep that like that, is 9 plus $1.75 times 12 is 21. So that means when they go on 12 rides, they're going to pay $30. So they spent $30 at the carnival. Now, I'm not saying you couldn't figure this out without doing all of this stuff. You could have gotten this 30 in your head or simple, but this vocabulary and this concept of input and output is really important going forward. It's something that gets used in advanced math often. So I want you guys to get a taste of it, okay? The last thing we want to talk about is discrete or continuous. This definitely has to be discrete because when you think about the rides, you can't go like on half a ride, right? It doesn't work that way. So you have to have individual points, either 1, 2, 3, 4, 5. So you're not connecting those dots. It's just individual points. We've got one last example. Okay. A lawyer's fee is $180 per hour for her services. Lawyers charge a lot, just FYI. How much does the lawyer charge, and what would the charge be? Sorry. What would the charge be for 5 hours? So now we're thinking what changes what? What's my independent and dependent variable? So I am not choosing the cost. I'm choosing how many hours I go see her. When I make an appointment, maybe the appointment's for an hour. I might make an appointment for 2 hours. So I'm deciding how many hours I want to see her, and then that changes the cost. So the cost depends on the hours. That means hours is my independent variable and cost is my dependent variable. The function I'm going to write for this one, remember, this is my input right here. That guy is my input. So I'm going to put f of h, and then how would I calculate the cost? Well, it's $180 per hour, so that's just 180 times h. So whatever many hours I decide to make the appointment for, I multiply 180, and that's what she would charge me for going. Evaluate means that instead of putting h there, I'm going for 5 hours, so I'm trying to find f of 5. So I'm plugging in 5 for h, and then I'm going to calculate, and 180 times 5 is $900. So they spent $900 for the lawyer. Now, this also has to be discrete because she's not going to charge for half hours. She's probably not going to give 90. If you're there for 4.5 hours, she's going to round up to 5. That's usually how these services work. So you can't have half an hour. Now, if you were to argue with me about this and say, oh, she went 1.725, I would find that unrealistic because there's no really good way a lawyer could say it's 1.275 hours and then calculate a charge. It just doesn't make sense in real life for that to happen. And we need to start thinking about real life. We need to start thinking about what these people are doing and what these real life situations look like. That's the important part of this learning target. So in your practice, I really want you to think about what changes what. What are you choosing? What depends on what as you go forward in this learning target? Okay? Good luck. I'll see you in class.